Hello, algebra students. Mr. Lawrence here with a flipped lesson. Now, this should be super simple, but I know some of you are going to struggle with it because you never learned how to solve these inequalities, or excuse me, how to solve equations the proper way. A lot of you were smart enough last year or the year before to just kind of look at an equation and just figure it out. Well, those days are over, and I've warned you about that. And now many of you are struggling because you just want to figure it out. I'm sorry to tell you, but you're not smart enough to do that anymore. And guess what? In many of the cases, I'm not smart enough either. I can from experience, but I do the steps. Okay? Stop just trying to guess. I've made a lot of these so they come up to be fractional answers on purpose to make it more difficult for you just to look at and go, hocus pocus, I know the answer. You have to follow the steps. All right, so I'm going to go over a little basic review. I apologize to those of you who've already mastered this, but make sure you watch and see what's going on. But I won't be doing this. Now, after you've gone through this video, you may want to watch it more than once, especially if you're one of those kids who doesn't know how to do the equations step by step. And then you also may want to come in for help. There will be help um, well, Wednesday night. I guess you'll be listening to this Wednesday night. Hopefully you came in that day. All right. Anyway, so say we have this inequality here. We have to solve for x. We're going to solve it just like a two-step equation. So the way I taught it back when we did solving equations was, first of all, to ask yourself, what is my goal? And you should all know that. It's not to figure out what x is. Your goal is to get x alone. It's not to figure out what x is. It's to get x alone. If you think the way I'm telling you to think about this, it'll be a lot easier. If you want to figure out what x is, you're going to guess and check, and you're not going to get the right answers. And a lot of you are starting to get lower grades than you've ever earned before. You need to be following the techniques that I'm teaching you. Okay? And if you don't agree with that, I'm sorry, but your way doesn't work any longer. Trust me and my experience. All right. The second question is, what numbers are keeping the x from being alone? Well, in this case, there's a 3 and a 7. When I say keeping it from being alone, remember I'm talking on the same side of the inequality in this case. I can't say equation because there's no equal sign. It's a greater than sign, and so I'll say inequality. All right. How are they attached to x? Well, the 3 is attached by multiplication. 7 is attached by subtraction. Okay. How do I undo those? Well, I undo multiplication with division, right? I use the inverse operation, and I undo subtraction with addition. Again, I use the inverse operation. Now, I was very surprised on Monday to have to answer this question for somebody. Which do I undo first? Well, I have to listen to Saddam. I undo subtraction, addition, and then I undo division and multiplication. Okay? A lot of you are going to go to undo the multiplication first, and you can do it that way, but you're going to do it wrong because I've graded your papers and I've seen you. Please follow this way. It works. I came up with this technique. I'm not going to say I created it, but I came up with it on my own. Nobody taught it to me, and I've seen it work over the years. If you want to be stubborn and continue to do your way, make sure you're getting it right. Okay, so I'm going to come over here and I'm going to undo the subtraction. I'm going to undo it with addition. There's a 7 there. I want them to cancel. I'm going to add 7 to both sides of the inequality. When I do that, I'm going to end up with 3x is greater than 22. And now I'm going to undo the multiplication with division. Notice I don't use a division sign. I use a fraction bar. Trust me, it's a lot easier. Okay? And then I get x, and that's going to be greater than 3 is going to go into 21 7 times. It's going to be 1 short, 3 goes into 22 7 times. It's going to be 1 short of 22, and I divide it by 3. So x is greater than 7 1/3. So any number greater than 7 1/3 is a solution to this inequality. 7 2/3 comes to mind. 8, 8 1/2, 1,000. Any one of those numbers will make this a true inequality. Okay. So now that you've seen how I do it, I'm going to go through these again, these other sample problems here. Hold on a second. There's number 2. Okay, I know my goal is to get x alone. I know that I have a 5 and I have a 2. How is the 5 attached? Hopefully you know it's attached by addition. Why is it addition? Because it's a positive 5. This negative belongs to the 2. So if you want to say there's a negative 2 attached to x, and it's attached by multiplication. I'm going to undo this addition with subtraction and multiplication with division, and I'm going to listen to Saddam. I'm going to undo the subtraction and addition before I undo the division multiplication. All right, now to get rid of this 5, I have to put minus 5 here. Some of you are going to write plus 5, and then you're trying to tell me that 5 plus 5 is 0. You know that's not true. Stop doing it. Use the inverse operation. All right, so the left-hand side is going to become negative 2x. Be careful to not lose that negative. He's very important in this problem. And the right-hand side is going to become 15. And then I am going to get rid of the negative 2 by dividing. Now, when you divide by a negative 2, something very special happens. Of course, I have to do it to both sides. But when I divide by a negative or multiply by a negative, my inequality is going to flip. Say that. When I multiply or divide by a negative, my inequality flips. So what I get is x is greater than or equal to negative 7.5. Now some of you are going to wonder why. Well, I'll show you the long way. Here's why. Okay, negative 2x is less than or equal to 15, right? I don't like this being negative. So I'll tell you what I'm going to do. I'm going to add 2x to the left-hand side and add 2x to the right-hand side. Okay, this becomes 0, is less than or equal to 2x plus 15, right? Okay, now to get x alone, I need to subtract 15 from both sides. And so I will do that, minus 15, minus 15. Okay, and then I'm going to write it over here because I'm running out of room. I'll get negative 15 less than or equal to 2x. And then finally, I'll divide both sides by 2. Okay, I'll get negative 7.5 less than or equal to x. Now look at these two answers here, these two solutions. I get this, and I get this. Okay, what's the difference between them? This one says that x is greater than or equal to negative 7.5. So for example, like numbers like negative 7, negative 6, negative 1, 0. So 0 and 1 and 2 all make this a true statement, right? It's all the numbers that are greater than or equal to negative 7.5. And this one says negative 7.5 is less than whatever x is. Well, what numbers would make this true? Well, negative 7.5 is less than negative 7. It's less than negative 6. It's less than 0. It's less than 1. It's less than 2. The same numbers make it true. These are the same statement. They're the same statement. The inequality flipping is just a shortcut. It saves me 2 steps. Notice I had to add 2x to each side and then subtract 15 from both sides. I divide each side by negative 2, and I get x is greater than or equal to negative 7. Whenever I multiply or divide by a negative, I flip the inequality. The inequality changes direction. Less thans become greater thans if I multiply or divide by a negative. All right, take a look at this one. I see a negative 4 attached to x by division. I see a 6 attached by addition. I'll get rid of the addition first. And when I do that, I'm going to get negative x over 4. And that's going to be less than 34. And then I need to undo the division with multiplication. I'm going to multiply both sides by negative 4. Negative 4 over 1 on that side. And I'm going to get quite a large number here. 2, oh no, not 2, excuse me. That's going to be a 6. And I'm going to carry the 136, I believe. And then over here, the 4's will cancel and the negatives will cancel, leaving me an x. And look at that, Mr. Lawrence made a mistake. I multiplied or divided by an x, didn't I? I multiplied by a negative. So my inequality needs to flip. There we go. X is greater than negative 136. All right, one last problem and then I'll let you go for the night. And again, you may want to watch this again. I expect you to already have mastered how to solve multi-step equations. If you haven't mastered it, you have to get practice with it. You better come in at lunch. You better do some extra time on it. This is the same thing, except you've got that inequality to deal with. All right, here I've got an 8, and again, the 8 is attached by addition, and I've got a negative 2/3 attached by multiplication. I'll get rid of the addition first, and that will leave me with negative 2/3 x is greater than or equal to 4. And then I'm going to divide by negative 2/3 and divide by negative 2/3. Hopefully you're recognizing that the inequality will need to flip, and this side of the problem becomes 4 over 1 times negative 3 over 2. And I hope you're still not being stubborn saying, well, I'm going to do 4 times 3. Do 2 into 4 2 times, and 2 times negative 3 is negative 6, and there is your solution. All right, that's it for the lesson. I know some of you aren't going to like a couple of things I said, but I'm telling you, I know where this course is going, and I know where the honors class is going. And if you're choosing to keep doing it your way, when your way only works on easy problems, you are going to become less and less successful in math as you go up and up the ladder. Trust me on this. Try these techniques I'm showing you. If you don't understand them, get your butt in for help. Not enough of the honors kids are coming in for help on a regular basis. You have holes in your learning and your grades are already starting to drop. All right, Mr. Lawrence signing off. Have a good night, everybody.